Equation of a line. Now we are talking about this line. We can say that equation of a straight line. We are talking about this line here. We want to find the equation of this straight line. This C here, we call it y-intercept. Y-intercept simply means that where that line touches the or crosses the y-axis. If it crosses the x-axis, we call it s-intercept. Now, this is equation of a line. This is how it looks like. That is a linear equation. Now, the general equation of a line is of this form. This is general form of a linear equation. Y is equal to mx plus c. Y equal to mx plus c. So this is the general equation of a line. What is our m? M is the usual meaning, which is gradient. We said in our last video, we said M is gradient, while C is still the meaning of this C here, which is y-intercept. So that means if an equation of a line is written in this format, then we can know what is our gradient from it, and we can know what is our y-intercept from it. Let's take an example on this. We have an example here. Find the gradient from the following equations of lines. Now, this is the first one, y equal to 4s plus 3. Now, the coefficient of s here is our gradient, just like what we have here. The coefficient of s is the gradient. Therefore, I will say that the gradient is 4. This one here is our c, which is called y-intercept. Now, if I consider another example, let's say I now have y plus 3s is equal to 9. You observe that it is not of this nature. So you need to just express it in this format. That is, you make y the subject of formula. If you make y the subject of formula, you are going to have that y is equal to minus 3s plus 9. So in this case now, the coefficient of s is our gradient. Therefore, I can say that my gradient is equal to minus 3. You see that also my y-intercept here is 9, but it is gradient that we need. So this aspect is very important to know how to locate gradient when you see an equation of a line. Let's consider a general case, which is this one. Let's consider a general case. Let's assume that we have 4y plus 3s is equal to 7. To do this, or any type of this general equation, you only need to find a way of making y the subject of formula. And how do we do that? Let us first retain this, so that we have 4y equal to 7 minus 3s. I've taken plus 3s to the other side. From that place, we now have that y is equal to, we divide both sides by 4. Y is equal to 7 over 4 minus 3 over 4x. So the coefficient of x, this is the coefficient of x. Our gradient is equal to minus 3 over 4. Because minus 3 over 4 is our coefficient of s. So that is how to find gradient, or to locate gradient when equation of a line is given. Example 2. Find the angle between the lines, this and this line. And we know I've given you the formula for finding angle. If you still remember, we said that it is arctan m1 minus m2 over 1 plus m1 m2. If you can still recall the formula. So what we just need to know is that when you are finding angle between two lines, we need the gradient. So in this case, we need to find the gradient of this one. So for 3y plus 5 is equal to x. If you want to find the gradient of this one now, our answer will be equal to, if you make y the set of formula, we have 1 over 3x minus 5 over 3. That is if you make the gradient the set of formula. In that case, our gradient here is equal to 1 over 3. Is equal to 1 over the coefficient of s. Now in this case, for the second one, for y plus 3x equal to 7. Making y the set of formula, we have minus 3x plus 7. In this case, our gradient is equal to minus 3. So I have told you the one that is higher would be m1. you will now see that 1 over 3 is greater than this. So I will call this M1, I will call this M2. So in this case, I can now find my angle between the two lines using this formula, M1 minus M2. That is 1 over 3 minus M2. Our M2 is minus, so I'll put over 3 there, divided by 1 plus M1 times M2. 1 over 3 times minus 3. This is arctan 1 over 3 plus 3. That should give me 10 over 3, divided by, this cancel this. All we have left here is minus 1. Then we are going to have 1 minus 1. So in this case, our answer is arctan 10 over 3 divided by 1 minus 1 is 0. And anything divided by 0 is infinity. So this is arctan infinity. Arctan infinity is simply 90 degree, because tan 90 degree will give me infinity. In that case, arctan infinity is 90 degree. Therefore, theta is equal to 90 degree. In fact, since theta is 90 degree, you know what 90 degree means. This is sine of 90 degree. We can quickly conclude that the lines are perpendicular to each other. Perpendicular. Because the angle between them is 90 degree. We can quickly conclude that the lines are 90 degree. So what we want to gain here is that how do we locate gradient from an equation of a line. Another example, find the value of k for which this line and this line are parallel and perpendicular. Let's say A parallel, B perpendicular. The first thing is, whenever we are talking about parallel and perpendicular, I've explained in the last video, we need gradient. So in this case, let us first find the gradient of this one. So for x plus 3y is equal to 2, the gradient, if you make y the same formula, we should know that y will become minus 1 over 3x plus 2 over 3. In that case, our gradient is minus 1 over 3 here. Also, for the second one, 2x minus ky is equal to 9. If you make y the same formula here, then y should be equal to 2 over kx minus 9 over k. In that case, my m is equal to 2 over k. So I have known the value of gradient here and the value of the gradient. The gradient here is minus 1 over 3, and this one is ordinary 2 over k. Now let's now consider the first one. The first one says parallel. If they say that parallel for parallel, we have said this before, that if two lines are parallel, then m1 must be equal to m2 when two lines are parallel. So this, let's say this is our m1, this is our m2. So this implies that 2 over k must be equal to minus 1 over 3, since the two lines are parallel. So in this case, let's cross multiply. If we cross multiply, we are going to have that minus k equal to 6. Therefore, k is equal to minus 6. So k will be equal to minus 6 if these two lines are parallel. For perpendicular, we have said that m1 times m2 must be equal to minus 1. So this is our m1, this is our m2. So in this case, we can now have, this is our m1. Our m2 is 2 over k times 2 over k equal to minus 1. So this will now imply that this minus will cancel this minus. What we have left is 2 over 3k is equal to 1. If you cross multiply, we are going to have that 3k equal to 2. Therefore, k is equal to 2 over 3. So k is equal to 2 over 3 is the value of k if these two lines are perpendicular. So that is that about that. Now let us now move to how to find equation of a line. Now moving to finding equation of a line. How do we find equation of a line? The other one now, they have found it already. Now we want to find equation of a line. Now, equation of a line exists in different forms. So we have to consider these forms. The first one, I'll consider case 1. Case 1 is that if that line passes through one point s1, y1, it passes through s1, y1, and the line has a gradient. That simply means case 1, it simply means that if you are given one point and a gradient as well, this is the formula we use. This is the formula for finding equation of such line. In fact, anytime we want to find equation of such line, we must know the gradient and we must also know a point that the line passes through. So in this case, let's take example on this. Example 1. Find the equation of a line that passes through point this 5, -1 and has gradient 2/3. So in this case, you see that it's the same thing as this. That is, we are given one point and we are given a gradient. So in this case, s1, y1 is given, m is given, which is 2/3. I will now use this formula. I will follow the formula like that. Y is there like that, minus y1. These are y1 here. That will now become plus 1 because of that minus, over x minus x1. This is our x1, which is 5, equal to m. This is our m here, 2/3. That is all. You only need to simplify to get your answer. If you cross multiply, you are going to have 3 into y plus 1 is equal to 2 into s minus 5. If you cross multiply, if you expand, we are going to have 3y plus 3 equal to, this one will be 2s minus 10. So this is 3y equal to 2x minus 10. When this one comes here, we have minus 3. So I can say that 3y is equal to 2s minus 13. And you can arrange it anyhow you like. You can bring all this in or just take this one to this place. You can say that 3y minus 2s plus 13 equal to 0, or you can decide to take this one to this. Anyhow you arrange it is an answer. 2y minus 3y, 2s minus 3y minus 13 is equal to 0. So it's also the equation of line. So we have found the equation of line that passes through this point and has gradient. So anytime we are given, this is the formula we always be using. When an equation passes through a point and has a gradient, so we'll make use of this formula, or you can, it's still the same, we just cross multiply, or you use this directly. So you need to pause and study it. This is another case. This is another case for the equation of a line. We have considered when a line passes through one point and has a gradient, but here now it passes through 2 points. When a line passes through 2 points, there's no gradient here. So the equation of line is given as this: y minus y1 over s minus s1 equal to, you observe that this sign, this formula is simply the formula for gradient, which is still the first case that we are writing. We only wrote our m in terms of y2 minus y1 over s2 minus s1. So that means if a line passes through 1 point and 2 points, we make use of this formula for such equation of a line. So let's take example on that. Example: find the equation of a line passing through 2 points, this 7,3 and 4, minus 2. 7,3 is our s1 y1, s2 y2. So in this case now, this equation passes through 2 points. That means we are making use of this. So in this case, we only need to recall the formula. Our answer is just 1 y minus y1. This is it, minus 3 over x minus x1, which is 7, equal to y2 minus y1 minus 2 minus, these are y2, minus 3 over s2, 4 minus s1, 7. Here, if I simplify this one, I will have minus 5 over, if I simplify this, I will have minus 3. You observe that minus cancel minus. What we have left is 5 over 3. Let us just cross multiply. This times this, I'm going to have 3 into y minus 3 equal to 5 times this, 5 into s minus 7. If you expand, we have 3y minus 9 equal to, this one will be 5x minus 35. From this place, you are going to have 3y minus 9. Let's bring all this inside. Minus 5x plus 35. Take note that you can arrange any how you like it. Then you can simplify this one to get your final answer. So let's move to case 3. Case 3. When the x and y intercepts are given. So that simply means that this is a straight line here. I told you where this line cuts x-axis here. Do you know this x-axis? This is y-axis. Where it cuts x-axis here is called s-intercept. Okay, s-intercept at A. Okay, this is, let me say this is A. This is B from the statement I wrote above. If it cuts x-axis at A, this is our A, x-axis, and y-axis at B, that is the value in this place, this thing is B. So we call it an intercept form or canonical form. So we call it canonical form, or we call it intercept form of equation of a line. So this is a formula. So when they say that you find an equation of a line and you are given the intercepts, that is where the line cuts x-axis and y-axis, it will be x over the value at x-axis plus y over the value of at y-axis is equal to 1. So take example, find the equation of a line that cuts x-axis at 3 and then y-axis at minus 5. We want to find such equation of a line. Our answer is just x over the value at x-axis plus y over b. Our b is minus 5. You can see that this topic is simple. The only thing is that you only need to recall the formulas. So if you cross multiply or simplify, you are going to have 5x minus 3y equal to 15. So this is the equation of such line that cuts x-axis at A and y-axis at B. Now, let's now consider general question on equation of a line. Find the example 1. Find the equation of a line that passes through this point and parallel to the line this. Remember that I said anytime you want to find the equation of a line, you must be given a point and a gradient. Here we have been given a point, but we are not giving gradient, but indirectly we are giving gradient because the question says that line we are talking about is parallel to this one. Definitely by condition of parallelism, it will have the same gradient as this. So in that case, if I have known the gradient of this one, I will know the gradient of the line I'm talking about. Now let me quickly say that from 4s plus 3y minus 16 equal to 0. Let's quickly make y the zero formula. So y should be equal to minus 4 over 3 x plus 16 over 3. So in that case, our m is equal to minus 4 over 3. That is the gradient of this line. But they said that the one we are looking for passes is parallel to this line. Definitely they will have the same gradient. By condition, we normally say that m1 is equal to m2 for parallelism. We normally say that m1 is equal to m2. In that case, they will have the same gradient. So I cannot use this formula. What we are not saying is that it passes through this point and has gradient minus 4 over 3. So I cannot use the formula y minus y1 over s minus s1 is equal to m. So that's the formula we have been using. Our answer is y minus, what's our y1? Is our y1 here, 2 over x minus, our x1 is minus 3. That will become plus 3 equal to gradient. Our gradient is minus 4 over 3. Then you need to, this will be this equal to minus 4 into s plus 3. So I don't need to further here. Then you can decide to, you can continue. You can continue to get your final answer. Now, example 2. Another example, find the equation of a straight line which passes through point 2, 4 and perpendicular to this line. Now, this one is talking about perpendicular. So the first thing is we have been given a point. We need a gradient. How can we find the gradient? We find the gradient from this one. Since they have told us that it's perpendicular to this line. Now, the first thing is, let me get the gradient of this. This is 2s plus 5y plus 3 equal to 0. If you make y the zero formula, y will be equal to minus 2s over 5 minus 3 over 5. Therefore, let's say my m1 is equal to minus 2 over 5, the gradient. Now, since I have known the gradient, which gradient am I looking for? Remember, we say m2 times m1 is equal to minus 1 for perpendicular. This is the formula we used to get our, so in this case we can use this formula to get our new gradient. That is our new gradient times m1. This is our m1 minus 2 over 5 equal to minus 1. If you make m the zero formula, our m is equal to 5 over 2. So it is this gradient that we are looking for. So in that case, we can use y minus y1 over s minus s1 is equal to m. So if I have known the gradient and I have known the point, it will just be easy for me. So our answer here will now be y minus, these are y1. Our y1 is 4 over s minus s1. Our s1 is 2 equal to m. Our m is 5 over 2. If you cross multiply, we have 2 into y minus 4 equal to 5 into s minus 2. So this will be 2y minus 8 equal to 5s minus 10. Then you need to simplify this one to get your final answer. Another example, find the equation of a line that passes through this point and midpoint of the line joining these two. So this one now is not giving us the gradient. It's talking about passing through 2 points. This is the first point. The second point is the midpoint of these 2 points. So you only need to know what's the midpoint. So the midpoint of this, you remember the formula s1 plus s2 over 2, comma y1 plus y2 over 2. So this is our s1. So what are we going to have? s1 plus s2. 2 plus 6 over 2, comma 3 plus 5 over 2. So in that case, the midpoint is this plus this is 8. That should be 4, 4. So what we are saying in essence is that the equation of that line passes through this point and also this point. So I will use the equation of a line which is given as this when a line passes through 2 points. So which I have given before. I will now have y minus, what are we dealing with? Let me write it out. 3, 5 and 4, 4. Our answer will now be y minus y1. Let me write it. y1 s1 y2 s2. Now this will be y minus y1. These are y1, which is 5, over s minus x1. So this is our x1, which is 3, equal to y2 minus y1, 4 minus 5 over s2 minus s1, 4 minus 3. This is minus 1 over 1. What we have is y over 5 over this is equal to minus 1. If we cross multiply, we have y minus 5 is equal to minus s minus 3. This will be minus s plus 3. If you expand the bracket, So if you bring all this one in, we have plus s minus 3. Finally, there we have y plus s minus 8 is equal to 0. So that is the equation of the line. For example, find the equation of a line passing through the point of intersection of these lines, of this line and this line, and is perpendicular to this line. Now the first thing is that you are given a gradient from this place because they are talking about perpendicular. And the second thing is point of intersection. What they are trying to say is that let's assume that the first line, this one is this, and this one is this. They are saying that the line we are talking about passes through the point of intersection here and is perpendicular to another line. That is what the question is talking about. The question is that how do you find the point of intersection of this line? Now, point of intersection of 2x plus 3y plus 7 is equal to 0. 3s plus 4y plus 10 is equal to 0. If they said anytime you hear point of intersection, that simply means simultaneous equation. So what they are saying there, point of intersection simply means simultaneous equation. So that is, we should find the simultaneous equation of these two. So I'm doing that, which I don't think I should do for you. I believe you have passed through that. So we will now need to find the simultaneous equation. When we solve the simultaneous equation, we should have that s is equal to minus 2 and y is equal to minus 1. So that is when we solve this simultaneous equation. So I don't need to teach you that. In that case, the point we are talking about is now minus 2 comma minus 1, which is our s1 y1. Now for the gradient, we need to know the gradient. We are told that the line is also perpendicular to this. It's perpendicular, so we can get our gradient from that place. That is 4s plus 7y is equal to 5. So we quickly need to make y the same formula. Y will be equal to minus 4s over 7 plus 5 over 7. Therefore, let's say our m2 is equal to minus 4 over 7. But the one we are looking for, we recall for perpendicular, we say m1 times m2 is equal to minus 1. So that means m times this must be equal to minus 1. Therefore, the gradient we need will now be what? 7 over 4. So I can now use the formula which says y minus y1 over s minus s1 is equal to y2 minus y1 over s2 minus is equal to m. So that is, we are given a point and a gradient. So we say is equal to m. Let me write it again. Y minus y1 over s minus s1 is equal to m. So from that place, I will now have y minus, our y1 is plus 1 over x minus, our s1 is minus 2, so it will become plus 2 equal to m. Our m is 7 over 4. So cross multiplying will give me 4 times y plus 1 equal to 7 into s plus 2. Then we can finish this one by ourselves. Let's take this as an assignment. Find the equation of the perpendicular bisector of the line joining this point and this point. Find the equation of perpendicular bisector of this line. Number 2, given the vertices of a triangle ABC, find the equation of a line through A perpendicular to BC. Find the equation of a line through C through A parallel to BC, and find the equation of a line through C perpendicular to AB. Okay, let me add more. Find the area of triangle ABC. So we'll take the assignment. When we resume, I will collect it. Another important topic on equation of a line: length of perpendicular line from certain point P, x1, y1 to another certain line. This, what we are saying is this: let's say we have point P here. This is a line AS plus BY. Can we find this length here? The length of this line, which is perpendicular. This line is perpendicular to this one. That is why we put right angle sign here. It's perpendicular. Can we find the length from certain point S1, y1? So the formula is simply given as AS1 plus BY1 plus C over square root of A square plus B square. So the proof is inside the textbook. Now let's take example on this. Example. Find the length of the perpendicular line. Find the length of a perpendicular line from this point to this line. We want to find the length of a perpendicular line from this point to this line. In this case, this is our S1, this is our Y1, this is our A, this is our B. So in that case, the formula is AX1 plus BY plus C over root of A square plus B square. So we only need to rewrite what is here. And whenever we see S, this is our S, this is our Y. So our answer is 8x. Our S is 3 plus is into Y. Our Y is minus 3 plus this 15 over root of A square plus B square. This plus C squared. From that place, 8 times 3 should give me 24 minus 18 plus 15 divided by, this is 64 plus 36. Now 24 plus 15, 21 over 10, or let's say 2.1. So that will be the length of that certain line that is perpendicular to this from point 3, 3. Let's take another example. Example 2. Find the length of a perpendicular line from this point to this line. So the first thing is, this is our S1, this is our Y1. Now you need to rewrite this thing in a single form. So that is 2x, take 5y to the other side, we have minus 5y. This is minus 7 equal to 0. We need to write it like this so that this is our A, this is our B. Then our formula, AX plus BY plus C over root of A square plus B square. So there is no problem. We only need to rewrite this out. Then we put S to be 2, our Y to be minus 4. So this will be 2 into X. Our X is 2 given here. Minus 5 into Y. Our Y is minus 4. Minus this 7 over root of, this is our A, this is our B. Root of 2 squared plus minus 5 squared. So if you simplify this, this is minus 5 times minus 4, that is 20. 20 plus 4 is 24. 24 minus this, that is 24 minus 7, that should be 17 over minus 5 square is 25 plus this, that is 29. So over square root of 29. So our answer is 17 over square root of 29 is the length of perpendicular line. Now let's consider more complicated one. Example 3. If M and N are the lengths of the perpendicular lines from the origin. Take note of this, from the origin. Origin simply means 0, 0 to the lines this, to this line and this line. Prove that 4m squared plus n squared is equal to a squared. Now solution. The first thing is that m is the length length of perpendicular line from 0, 0, that is origin, to the line. Where is the line? This is the line. X sec A plus y cosec A is equal to small a. So from this place now, I will now use the formula. I will use this formula. So in this case, our m will now be equal to ax. This is our x. So this will be 0. S, because it's origin, s is 0. You know, I only need to rewrite this thing. So s is 0. That will be 0 sec A plus y is also 0. 0 cosec A. This one will come in minus a. Don't forget that there's absolute value here, divided by square root of. You can see that I've been using a square plus b square. A is the coefficient of s. Coefficient of s is sec a. So I will have sec square a plus this one too, cosec square a. Normally this one is 0. We have minus a, but because of this absolute value, means I should neglect the minus. So our answer is ordinary a. Okay, there's no space there. This will be ordinary a over square root of sec square a plus cosec square a. What is sec square a? Our sec square a is just 1 over cos square a plus cosec square a is 1 over sin square a. So this is a over square root of, let's find LCM here. LCM is cosec square a sin square a. Find the LCM, this will be sin square a plus cosec square a. But we recall that, let's recall that sin square a plus cos square a is equal to 1. So in that case, this place is 1. So that means my m is equal to a over square root of 1 divided by cos square a sin square a, which I can simply, about square root we cancel this square. We can quickly write it as a over 1 divided by cos a sin a, or let us just write it as a cos a sin a. From this list, let me find the square, m square, because in that question there is square, m is squared. Now let us find m square. If I find m square, I will have a square cos square a sin square a. I will recall also, which I have given under trig identity, that cos square a is same thing as half into 1 plus cos 2a. Also, I've given you this sin square a is equal to half into 1 minus cos 2a. So in that case, our m square will now be a square into cos square a. This will be our cos square a, half into 1 plus cos 2a. Another one, sin square a, that is half into 1 minus cos 2a. Our m square will now be a square over 4. This is half times this half is 4. If we expand this, this is difference of two squares. It will just be 1 minus cos square 2a. So let's take that one as star 1. Now I am done with m. Also from the second one, we are told that n is the length of perpendicular lines to this one from the origin. M is for this, while n is for this. So from the second statement, n is the length of perpendicular line from, they said from origin, that is from 0, 0 to the line s cos a. What is there again? S cos a minus y cos b. Sorry. S cos a minus y sin a minus y sin a is equal to a cos 2a. Let us just bring this one here. So we have s cos a minus y sin a. If you bring this one here, we have minus a cos 2a is equal to 0. Now, what is now our n? I will use the formula. I will use this formula. As plus by is equal to over plus c over this. In this case, our s and y are 0. S is 0, y is 0. Our answer is absolute value of 0 cos a minus 0 sin a minus a cos 2a over square root of coefficient of s and y over cos square a plus sin square a. Don't forget that this one is 1. Cos square a sin square a. Just like the identity we used before. Where is the identity? This identity here. So from that place, I will now say that my n is equal to, if you observe, this is 0. What we have left is minus a cos 2a. But because of the absolute value, we will neglect the minus. It will just be a cos 2a over 1. That one is gone. I need n squared too. N squared will now be a square cos square 2a. Because from the question we are given, we have to find n squared too. What we have now found are this. M square has given us this, while n square has given us this. So in that case, what are we really looking for? I want to add these two together. So from this place, if you cross multiply, you are going to, from this one will be 4m squared. If you cross multiply, is equal to a square into 1 minus cos square 2a. N square is equal to a square cos square 2a. Let's add it together as required by the question. Because what is in the question, what the question asks us to do is to find 4m square plus n square, if it should be equal to a square. From that place, our 4m square plus n square, that is, when we add it together, it will be a square into 1 minus cos square 2a plus a square cos square 2a. If you expand, you are going to have a square minus a square cos square 2a plus this one is a square cos square 2a. You observe that this and this is gone. That is 0. What we have left is a square. So we have successfully shown that 4m square plus n square is equal to a square. So that is what the question asks us to show, and we have proved it. Now check this question here. The vertices of a triangle are these. Find the equation of line through C perpendicular to AB. Find the length of perpendicular bisector from C to AB. So this is the solution here, which you should study. I will not explain this. You should study it. This is the solution. This is the solution. Pause and study the solution. So it ends here. This is another important question which I want you to take note and study. This is the question, and the solution starts from this place. We need to first draw the diagram. Solution starts from this place. You must take note. Solution continues. Still continue. Could you imagine you meet something like this in your exam? So what will happen? Okay, good day. We'll meet in the next class.